Thanks, everyone. I was a bit surprised that this topic came up, sweet taste measurement. It's been something I've been doing my whole entire career, so I'm going, is this new information? And fortunate for you, I kept some of my files from NutraSweet. They weren't digitized, so I had paper copies of things that I had actually pulled out from 30 years ago to share today. So what I decided to title mine was Bitter Realities in Measuring Sweet Taste. It is more complex. It is a very simple, basic taste, but when you really get into it in the food system, beyond the water model systems we tend to evaluate, it gets pretty complex pretty quickly. So I wanted to introduce a lot of considerations around this topic, and I keep adding to this list as I think about it. Before I start, I do want to mention when I say sweeteners, I'm encompassing all sweeteners, whether it's, I tend to call them potent sweeteners, just so you know, just that's what we started calling it at NutraSweet, was potent sweeteners, and all these sugars as well, and sugar alcohols. So when you consider a sweetener for a food system and what it's going to contribute, certainly sweet taste intensity is the key thing, but it's not the sole criterion. And as you can see, my list kept getting longer and longer as I thought about it. All the questions that we get into in considering it for use in a food, and then there's a lot of sensory aspects to it that I can actually measure. So the first question, how much sweetness can a sweetener deliver? We talk about potency, purity, maximal sweetness issues, does the aftertaste linger, et cetera, et cetera. I'm not going to go through all of these, but what I just, when you finally get to the bottom and then you're actually going to put it in a food product, all of these questions are important in addition to the food structure. Is it a solid? Is it a liquid? Is it a semi-solid? The serving temperature. Obviously, a cold ice cream versus a hot coffee versus a room temperature product is going to really affect your perception as well. Stability during production or home preparation. So aspartames, issues with baking. You couldn't bake with aspartame. It didn't survive those high temperatures. And then shelf life issues, obviously. So that's more in the world of food production. But what I wanted to talk about is I'm just going to lift from this very specific aspects. I'm not going to go through everything. I don't have time. So if you have questions on these other things, we can talk later. I'm just pulling things I think would be of interest to you and you're trying to understand how to measure sweet taste. But to give you some background on why I'm talking about sweetness intensity, when we think about a stimulus leading to a sensation, that's the perception piece. I'm interested in the response piece and some judgment that the individual or panelist is going through to come up with that response. And in my sensory world, for sweet taste, there are three main responses that I'd be interested in. One is qualitative, so a description of what they're actually perceiving. What is it? And I find that the sweet is one of those things that I'm comfortable asking anybody about. A consumer knows what sweet taste is. I feel like people know sweet taste. And I'm comfortable asking about sweetness. Unlike, say, sour and bitter, which a lot of people confuse those two, sour and bitter tastes, for example. But sweetness, everyone's pretty confident they know what it is. The thing is, that just describes it. The next thing would be intensity. How strong is it? How much sweetness is in there? That would be my next question. And then finally, we get into this whole world of hedonics, which is very complex. So is it liked? Is it disliked? Is it preferred over something else? That's a very different question. So for focus today, as we've mentioned before, I'm going to focus on intensity. So how strong is that sweet taste? And we do have methods. We already have methods out there. We've been using them for decades. The two big camps, I think, are determining a point estimate. So here you're trying to find a very specific concentrations that's equivalent to sucrose. And sucrose is the gold standard, and sucrose in water is the gold standard. That's what we always tend to compare against. So the one on the left, I'm not going through the method here. I'm going to leave methodology to Paul. He's going to cover that later. But you're really just finding a very specific point that gives you, say, equivalent concentration to, say, a sucrose equivalency, or even across different sweeteners. The second one would be using a highly trained panel. In our world, it's called descriptive analysis. And you're going to model it across concentrations. So you have a concentration response curve versus the concentration there. You see percent sucrose on the side. I'm going to just comment a bit about this percent sucrose over here on the left, because you see it's a 0 to 15 scale. It's commonly used in one of the descriptive analysis methods out there, the sensory spectrum method, but it provides a good anchor point. The panelists are actually anchored against these concentrations. So by anchored, I mean they actually taste these concentrations to compare their ratings to. And that's important, I think, in any sensory work, is they have some sort of context to evaluate the sweet taste. They're really good at comparing it to something, but if you just ask them out of the blue, how strong is it, it's going to be very difficult to interpret that. And you can see we have different lines here. We have Rhabdioxide A, sweetener X, I can't tell you what that is, and Mogroside 5, which is in the monk fruit. I actually quite like that sweetener. But one other comment about this percent sucrose, I've been thinking about your issues. You think about 15% sucrose, well, maybe that's not high in sugar, but in a food system, I had found this scale works amazingly well. And most foods, I've rarely see foods go below 2. You're starting to get into threshold issues there. Rarely go above 12, say, on this scale. So if you're talking about all foods out there are falling in this scale, and that doesn't give you a lot of room for, there's so much complexity, and I'll explain that later. You're not in a pure system. So I'm very comfortable working with up to 15% sucrose as far as my reference point for sweet taste. Another, just an aside here on this potent sweetener, some potent sweeteners never attain a level that we need as a sole sweetener in a food. For example, Rhabdioxide A tends to plateau out around 7, so you could keep adding more Rhabdioxide A, which is a key component in the stevia sweeteners, and you'd never retain maybe the level of sweetness you need to deliver in your food. So you'd have to mix it with another sweetener. It's just as an aside. So my comment is we have ways to determine these concentrations of sweet taste, but it doesn't tell the whole story, and I have something called the taste like sugar story. So when I worked at NutraSweet late 80s, we had this, late 80s, I'm trying to remember my career. Anyway, we had this claim that it tasted like sugar, and we were challenged on it in Australia. And so we had to go down there and do some rather not sophisticated, but just we had to do a lot of testing down there. And I think the N on this was like 1,000 people. It was a really large study. And we very, very carefully used our methodology. We had a lot of data to say the aspartame was isosweet to a very specific concentration of sugar. And we picked a level that wasn't too extreme. We did it in room temperature water. And the question we asked the consumer was, which one tastes like sugar? That was the only question they had to answer. So it was really directly attacking that claim. So we were kind of nervous about it, because in my world, in the sensory world, nothing quite tastes like sucrose, even though I couldn't say that working for NutraSweet. But we went there, and lo and behold, more people picked aspartame than sucrose as tasting like sugar. And we were like, well, that's great news for us, but I was trying to understand why in the heck would they say that. We did have a comment question on there, and we started going through the comments. We realized the reason they selected that one was because they said it was sweeter. And we're going, what? No, we've got reams of data saying this is isosweet. Well, you know what I forgot. I think a lot of you know what I forgot, which was the aftertaste issue. So move ahead 20 years, and I'm working in a solid system. This is data from a real product when I was at General Mills, and we were working on a very much reduced product. You can see at the top, we had very carefully calculated how much we needed to include of this potent sweetener. We still had a little bit of sugar in there to be equivalently sweet. And so the sucrose line is the black dashed line. The potent sweetener we launched with was the red line. And I think you can see my story right away. But sucrose and carbohydrate sweeteners in general clean in the mouth really, really quickly. So again, my 15-point scale went from 10, almost lost half the sweetness a minute out. A minute out is a long time when you're waiting, eating food. But look at the potent sweetener. It had only gone down a couple. It was hanging around in the mouth, and of course, the consumer's going to say, that's more sweet. It's lingering, it's cloying. So we ended up having to reformulate to the blue line, which was a compromise between the initial taste and 60 seconds. But in the world of food companies, we'd already lost those consumers, even though we reformulated. You know, they weren't going to go back to it. So not a good story. And you'd think I would have known this, you know, having worked at NutraSweet, but I forgot. Another issue is the potency issue. You listed a chart with, someone listed a chart with all the different potencies listed out there. For aspartame, this is a really old chart and it's hard to see, but the point is, at the lower concentrations of aspartame, the potency is much, much higher. You don't need as much, it's just not a linear relationship is what I'm saying. So when you tout that aspartame or ACE-K have a potency of 200, this is where you are in the chart. And I've noticed that it was done in cola. So when we first went out with NutraSweet, it was only approved for use in carbonated beverages. So, of course, all of our reference points at that point were in cola, and that roughly equates to 9 degrees Brix, or percent sugar roughly. It took about 450 parts per million of aspartame to be equivalent to that. But if you were formulating at a much lower concentration of sugar, you would, and if you just used the 200 times, you'd way overshoot. So it's an important point to remember. So you really need to understand the sucrose equivalency level when people are talking about potent sweeteners, and you need to identify the food system. So this would be, I'll show a picture later here. But sugars can also vary in potency. I thought someone mentioned something about no higher than lactose, which is really quite low in terms of sweetness contribution. So I just pulled this out of a textbook, literally. We've been looking at this for a long time. So, you know, Schutz and Pilgrim did this in 1957. They're highly respected psychophysicists, and I know they did great data collection. I don't know the methodology, but again, you see, I trust these numbers. The sucrose reference line is at 1, everything compared to sucrose. And you'll see up on the top that fructose is a tad higher, and so often we talk about, well, let's replace with fructose because maybe we can deliver more sweetness with less total sugar content. But in my experience, once I get into a food system, it's really negligible. You really can't. That level of quote-unquote potency is not buying you much. The other issue I wanted to bring up was the eating issue. So if you're talking about the diet or actually people consuming a food, we do so much of our work in the laboratory on that single first bite. You know, what happens, and it's a very, like 15 mils or whatever it is. It's very controlled. But look what happens when you take repeated bites, and this is tracking the sweetness intensity the entire time by the panelist. So it's kind of a complex task. But we had them track it. Every 30 seconds, they would take a sample in the mouth. And you can see the sucrose and most carbohydrate sweeteners are either go up a little bit or just give you a nice hit every single time. But if you look at some potent sweeteners, you start to decline. And we noticed this at NutraSweet when working with colas, even with aspartame, and in particular, some potent sweeteners even show a really significant decline. And you can do it yourself. You just take a regular Coke and a Diet Coke, and just take these steps every 30 seconds, and you'll notice it. It's really pretty interesting. So this is why when I go out to consumers, I would always ask them to eat a minimum of 3 bites or 3 sips before they even start answering the questions on my ballot, just because I know that initial taste is very uncharacteristic of what they fully experience in eating the product. So all the confounding factors in food, they're huge. Other sweeteners, this aspartame A12K synergy, as they say, is quite dramatic. And we corrected for potency differences here. This is an old chart, but we got up to more than 30% more sweetness than expected. And these are some charts that John Hayes sent to me. You can see that it also varies by sucrose equivalency, but again, you continue to see more sweetness than expected when you pair the two together. I haven't found any other sweetener blend quite as dramatic as this. This is the one I find all the time. And sugar plus potent sweeteners are much less synergistic. The other thing you have going on are other basic tastes in the system. So something called mixture suppression. So again, this is data from Harry Lawless in 1977, replotted. And I'm not going to go into detail on the chart, but what I wanted you to take home was when you blend the sucrose and the quinine is quite bitter, it's a known bitter reference, you can see bitterness drops by 38%, sweetness drops by 29%. So that's kind of getting into this, we're going into this 0 to 15, things are kind of compressing. Other food systems, this is really old data, but here we have different beverages, one with high fructose corn syrup, one with sucrose. You can see on the right-hand graph that black line is a straight line. The panelist is anchored to that. So, 5% sucrose is 5 on the scale, 10% sucrose is 10 on the scale. It's a very straight line, but the minute you start putting it in other things with it, that tends to come down. So the green line for tea is quite linear, but you start adding flavor, you start adding acids, you start adding caffeine, you start adding carbonation. It gets complex pretty quickly. And even consumers pick up on this. So we had a couple of products, and I don't know the actual percentage concentration if this was in a batch system. So don't pay too much attention between the 18 and the 24 grams sugar, but in increasing the sugar, these different measures, and again, this one I actually asked consumers intensity. I don't like to because they're not trained, but it was a 7-point scale, and even with their untrained status, they definitely can see that as you add sugar, the sourness and bitterness goes down, and the strawberry flavor goes up in their mind. Nothing has changed about the system but the sugar content. So this enhancement, as we see for the strawberry flavor, is pretty common. And on the flip side, a lot of times, you mentioned vanilla, a lot of times we will work to add vanilla or sweet flavors or fruit flavors to try increase or enhance the perception of sweetness, even though a trained panel might be able to tease that out. So my bottom line is it's going to be very difficult to pick a model system to evaluate all sweeteners. It's just so complex. So as I thought about this, we do have very valid methods for measuring. As you mentioned ISO, and those are very, those are very generic methods. If you look at ASTM or ISO methods, they're kind of generic across the system. Doing a sensory profile is exactly what I've been showing you. I forget what the other one was, but I'll get into ASTM in a minute. You really need to define what is to be measured and when within the consumption experience. You need very strict protocols, as you all know, around the sweetness level. What carrier are you going to use? Do you use water, or you do a proxy for food or beverage? Do you use acidified water, for example, to represent carbonated beverages or lemonade? And you may need to include screening of respondents for sensitivity. So by this I mean A-sulf-MK and saccharin are really bitter to some people. When I was working at NutraSweet, my rough estimate in the US population is about 30% are very sensitive to that bitterness. So if they're in your panel and you're trying to evaluate A-sulf-MK, you keep adding more ACE-K, and they're just going to be going, oh, I can't take this anymore. It's getting more and more bitter. So you may need to think about who you have do the evaluations for you and how you screen for that. And then given this complexity, you might have to go to a sweetness index of some sort, like a composite score based on several measures. I don't know what that is. I'm just thinking out loud. And ASTM could provide a means to standardize and publish these. I'm going to get into that in my next slides. But I'm going to stop at this point and ask if any of you have any questions based on what I've just talked about. And then I'll go on, and my second half is about ASTM. Yeah, Rick?
So, given the theme today and your emphasis on scaling, where does, and sucrose being kind of the standard, where does it asymptote in terms of concentration? And is there any other sweetener that actually exceeds that level of sweetness at any concentration?
of sucrose and water. I might have to defer to others in the room, but yes, it does asymptote. But I want to say on that scale, I'm going to guess it's up around 25, 30%. I'm not real sure. Yeah, I don't. I just.
It would seem to be a good point to establish.
Yeah, and it is known. I mean, there's concentration response. Yes, yes. There are concentration response curves for other sugars. I just don't have it memorized yet in my mind. The other thing I should point out on that 0 to 15, I forgot, was, there are some foods that go beyond that scale, and we can go beyond the 15 when we evaluate it. Think of like maple syrup or something like that, or frosting even. But those are products that are intended to fully bring almost a sweetening into the system itself. You know, they're almost a sweetener in and of themselves. But if I do the frosting or the icing that goes on a cake, it's way up there on my scale. But then I turn around and put that on a cake, and I have the panelists evaluate the whole cake, it's going to be back down in that 0 to 15 range. So it's pretty consistent. Yeah, Kays, did you have some comment about
This is very interesting. Thank you very much. It's, all the examples you've given are about one food or one beverage. How would you go about estimating the sweetness of a meal or of a diet?
Yeah. That's really, really complex. I mean, the closest experience I have is like a menu item. So we at General Mills had Hamburger Helper, which is, a combination of a pasta and a sauce and a protein like hamburgers or chicken or something like that. And you can do it. You have to ask them to eat, very specific bites and do all this, overall thing. The ballot itself gets really, really long, so you have to have a highly trained panel. But as far as a diet, oh boy. I don't know if you'd have to do them individually, and then, because you can't necessarily, I know what you're saying.
Many of the questions we were asked to think about are around how exposure to a certain level of sweetness in the diet could affect future preferences or intake or behaviors. So sooner or later, we have to address the question of exposure via the diet as a whole.
Yeah. I mean, one thing I was thinking of was someone mentioned a sweet tooth, and I mean, anecdotally, I almost put people in two camps. It's almost like a sweet tooth versus a salt tooth, and some of that seems to be so inherent in something. Any of you who've had children notice how different sometimes their taste preferences can be from day one. And so what's that all about? I don't know. So, Kays, did you?
Well, with respect to Rick's question, I think sucrose is probably you can get a higher sweetness level with sucrose than any other sweetener. And I think during my PhD I worked with very intense sucrose solutions up to 70 grams per 100 milliliters. And I think that would be about the maximum you could go, and there's no other sweetener which goes beyond that. It's sickeningly sweet.
Someone in the back had their hand up.
How do you factor in the question of smell? Because we know that smell is the other sort of sensation that influences perception of taste. So in any of these studies, do you take that into consideration when comparing?
I mean, the individual is taking that into consideration. They're giving me a sweet rating.
So you think that the individual who's being tested is actually using smell?
Yeah, they could be. They could be. We don't know necessarily what's going on in the brain, but they're familiar. We know, for example, that flavor enhancing property that we just talked about. When I say the strawberry flavor, I'm really talking about the aroma. There's not necessarily a taste, right? It's in an aromatic, but you will see people, because they've made the association, or they've become familiar with some of these flavors being sweet, they will automatically raise their sweet value just because the strawberry flavor is present and vice versa, and you kind of saw that there. The trained panel may be able to separate that out. They've been highly trained to think about odors separately from taste, but even so, that's not always true. Yeah, yeah.
So I think the same line of questioning. So when you do the sweetness and there's flavor component, so when you ask them for sweetness, do you try to block the retro-nasal aspect of it, blocking the nose?
Yeah.
Something like that, so that you don't have that impact from the flavor.
Yeah, and I haven't done a lot of that. I mean, obviously, I'm working in a food company, so we're interested in that total perception. But like I said, the trained panel are pretty good at, saying that's not a smelling something doesn't necessarily give them a sweet rating, so to speak. Yeah,
I'm thinking when they're chewing it.
Yeah. Yeah, it's hard because it's going to go up to the, retronasally anyway, so it's very difficult, yeah.
In doing the kinds of work and studies that you've done, I would imagine you see a lot of people over the time that you spent on this. And I'm interested in, if you were to formulate a product to be at the lower end of the spectrum of where people consider something to be sweet enough,
Uh-huh.
and the higher end of the spectrum
Mhm.
of where people consider something to be sweet enough, how different is the sugar content?
Good question. So you're talking about a difference threshold, basically. And my experience is roughly 10 to 15%. So a 10 to 15% change. And I say percent because, again, it gets harder to discriminate the higher up that scale you go. When you get really sweet, you have to make huge jumps to really detect that difference.
This is a really important question just because, an answer, because if we're considering safe or health effects, the differences in how much someone would consume of one kind of sweetener versus another, it's going to be in this, based on preference for sweet, it's going to be in a finite range.
Yeah. But I don't I don't know if I have an answer for it. All right. Well, if you think of more, you can ask me later. I'm going to move on and talk a bit about ASTM, which I've been a part of for many years. E18 is the specific committee within ASTM on sensory evaluation. Members represent industry. I didn't mention government as well, and academia. But the majority of us are coming from industry. We've seen fewer and fewer academics involved as time has gone on for various reasons. The standards are, the way we develop standards within ASTM is very rigorously defined by ASTM, and all these committees, you have so many committees in ASTM, everything from concrete to sports equipment to vacuum cleaners. I mean, it's just amazing to me. But it's a consensus-based procedure. Everyone votes on these. We have to decide, is this something we want to publish? But when you get to the final decision making, each organization only has one vote to make that final decision. The example that's been given to me is the paint committee. Apparently, the majority of the paint committee come from Sherwin-Williams. And so if you just went by majority rules, everything would be a Sherwin-Williams guideline, right? So all negative votes have to be addressed. So everyone has to be in agreement that this is the proper way to talk about it. And if someone keeps voting negative, you have to make a decision. You have to decide, is it persuasive enough that you have to go in and revise the ballot and reballot? Or is it something that is non-persuasive, as they call it? So you have to vote on that. You have to kind of give your reasoning why you don't think that person's correct. So it's a pretty rigorous process, which is why it takes a long time to get these through, believe me. And it's all volunteer-driven. These are people there volunteering their time. So we have had other organizations approach us in the past to develop a specific standard. It's not unknown to us. I just pulled out a few that I was familiar with. Standard guides for sensory claim substantiation. We were working with the National Advertising Council, the networks. They came to us because they really needed some guidelines instead of having the lawyers, duking it out in court who knew nothing about sensory. So we really worked out this claim substantiated doubt. How do you say something's preferred, for example, or has more of something, and all the good stats around it. So another one was, came to us from, I think, from another committee, fish taint. I know it sounds odd, but we helped them put in some good best practices, contaminants on odor and taste of exposed fish. It sounds really weird, but think about the BP oil spill in the Gulf of Mexico and how important that became as a way to evaluate some of the seafood coming out. Another one was the Metropolitan Water District of Los Angeles, who purchases water from all over, and they had some internal methods to evaluate materials in contact with drinking water. So these are like the pipelines and all this stuff that comes in. So they asked us to they wanted people to be using the same standard, and so we worked with them. We worked with their initial method, kind of made sure it followed best practices, was valid, had the right statistics, that kind of thing. So just a wide range of examples. So I looked through the different document types that you could consider through ASTM for sweet taste measurement. These are definitions that have come from ASTM. There's other types of methods, but a test method is very definitive, and you have a very specific way to do it and analyze it, and you end up with a result. So think about all our discrimination test methods, triangle method, tetrad method, duo, trio. Those are very specific ways to test. A guide is actually just recommendations around options. And my examples, when I brought to them, we were starting to do time intensity at NutraSweet, and this is where you track the intensity over time. And there was no one way to do it, but those of us that had gotten into it realized that, we learned a lot from trial and error, what worked, what didn't work. And so we felt it was helpful to our readers or to other sensory scientists to not have to go through all of that, and what would we recommend when you get into doing all the things you needed to consider. So that's how we ended up with a standard guide. Just some good, strong recommendations. A practice is really just a set of instructions. So operationally, how do you run a shelf life study? Or operationally, how do you study packaging? Not very specific as to a product or a stimulus. And I should mention, ASTM goes beyond food. It covers, in our committee, we work on toothpaste, or we might, anything that involves the senses. We have people from Procter & Gamble in there, Kimberly Clark, looking at paper towels, that kind of thing. So I think if you're talking about you want some specific method, you're talking a test method. You have to have a definitive procedure that produces a test result. But the thing is, the method already needs to be well defined. We're not a research organization. We're not going to just sit there and try a bunch of things. And so if you wanted us to work with you on it, you needed to have something really spelled out already, I think. And then we can help document it, get all the best practices, protocols in there, make sure everything's covered about, how you randomize and how you serve the samples and all that product controls that sensory scientists are so well known for. One thing that came to mind, and I haven't talked to anyone at E18 about this, but we have sponsored round robins before, studies with member labs to validate a method. So would there be a partnership that we could help evaluate different approaches? I don't even know if that's possible, but it would give you access if people agree to participate. So they're freely offering up their panels, their respondents under very controlled conditions. So you've got labs all over the country, and some in Canada and some in Europe. So it would give you access to quite a population of people in different locations, which might be kind of nice. There's the website there to give you some more information about ASTM. So that's what I have about ASTM.